This is the Math 7 study guide for the test on fractions, decimals, percents, square roots, and scientific notation. It also includes operations with decimals, and that's what we're going to do here. We do the 4 operations with decimals: addition, subtraction, and multiplication. That's supposed to be multiplication and division. Let's go through these quickly. The first one asks us to add 12.58 plus 3.99. 8 plus 9 is 17, carry the 1. 5 plus 1 is 6, plus 9 is 15, carry the 1. That's 6, and 1, line of decimals. Have some number sense. 12.58 plus, so 12, round about 12, plus 4 is around 16. That's how my answer was around 16. Have some number sense. 160 doesn't make sense. The second one, 1.4, subtract 0.76, or 0 and 76 hundredths. 1 and 4/10 minus 0 and 76 hundredths. Gotta line up your decimals and they add zeros. 0 minus 6 can't do it, so I borrow from the 4. The 4 becomes a 3. I bring 10 down. 10 minus 6 is 4. 3 minus 7, I can't do it, so I could look at it as 13 minus 7, but I want to show you some borrowing. The 1 becomes a 0, and I bring 10 down. So 10 more than 3 is 13. 13 minus 7 is 6. The answer is 0 and 64 hundredths. 0.64 or 0 and 64 hundredths. Know how to convert these decimals into fractions by reading them off. The next one is multiplication. If I wanted to approximate this, 22 times about 1, so my answer is going to be around 20-ish. Maybe a little bit higher, maybe a little bit lower, but again, it's not going to be around 200 or 0.2. 20 times 1 is about 20. Let's actually do the work. 22.45 times 0 and 92 hundredths. 22 and 45 hundredths times 92 hundredths. 2 times 5 is 10, carry the 1. 2 times 4 is 8, plus 1 is 9. 2 times 2 is 4. 2 times 2 is 4. Done with this 2 placeholder. 9 times 5 is 45, carry the 4. 9 times 4 is 36, plus 4 is 40. Carry the 4. 9 times 2 is 18. 18 plus 4 is 22. 9 times 2 is 18. 18 plus 2 is 20. At 0, 4, carry the 1, 10, carry the 1, 7, 0, 2. So my answer is not 207,000. Doesn't make sense. There's 1, 2, 3, 4 decimal places, so I move the decimal 1, 2, 3, 4 times. The answer is 20 and 704 thousandths, or 7,040 10,000ths. You can probably just drop that 0 though, they're the same thing. Number 4 asks us to divide. This divided by this, 252 and 5/10 divided by 0.25 by 25 hundredths means it's this divided by 0.25 if we wanted to rewrite it. So the top goes on the inside. 252.5 and 0 and 25 hundredths on the outside. The problem is the number on the outside, the divisor, cannot be a decimal. I move this over twice, I move this over twice, I reveal the 0. My new problem is now 25 divided into 25,250. Does 25 go into 2? No. Does 25 go into 25? Yes, it does. I put the 1 directly over the 25. Minus 25, there's 0 left over. Drop down just the 2. Does 25 go into just the 2 that got dropped down? No, it does not. Bring down the other 5. Does 25 go into 25? Yes, 1 time directly over the 25. That's 25 with 0 left over. 25 does not go into 0, and the decimals, we line up our decimals, so my answer is 1,010 for question number 4. Number 5 asks us to fill in, so let's read the instructions. Fill the remainder of the row by using your method. Show all your conversions to the right. Let's go this decimal to a fraction. Decimal to a fraction, if you read it off, it's easy to do. 0 and, 0 and, 0 and, tenths, hundredths, 42 hundredths. Now the only thing that needs to get done is it needs to simplify. 2 goes into 42 21 times, and 2 goes into 150 times, so the answer is 21 over 50. Turn this decimal into a percent. Do not be lazy. It literally takes seconds to do this. Some of you are trying to do it in your head. Write the number down. Don't be lazy. Move the decimal twice. It's 42%. 2/3. If I'm going to divide this, 2/3, I'll do this one in orange. The top goes on the inside, top goes on the inside, top goes on the inside, so 2 on the inside, 3 on the outside. Does 3 go into 2? No. decimal, 0, line after decimal. So 3 goes to 20, 6 times. 18 with 2 left over. Zeros drop them underneath. This 3 goes to 20, 6 times. That's 18 with 2 left over. So now if you notice, it is repeating. This is 0.6 repeating. Now how do I turn this decimal into percent? A lot of you guys will take this 0.6 repeating and you'll move it twice and you'll throw it into like something like this. This makes no sense. I can't have a repeating thing on the left of the decimal. Repeating bars are just to the right of decimal. Repeating bars are for decimals. They're not for these. So if you look, first of all, you thought that was a 0? There's a 0 here? No. This indicates it's all 6s. So if I do this, now you can see when I move the decimal twice, it's 66, and then a whole bunch of 6s repeating. So 66.6 repeating percent. Do you have to have the repeating bar? Yes. It has to be exactly like this, or perhaps like 66.666 repeating. Something to that effect, even 2 of them repeating. Those are all the same thing, but the repeating bar is after the decimal. For number, so the third one, 1.2, or 1 and 1 and 1 and 1 and 2 in the tenths place, 1 and 2 tenths. Please don't write, oh, 2 tenths simplifies to 1/5. That's incorrect. You're saying 1 and 2 tenths is equal to 1/5? That's not mathematically correct. Please don't say that. I understood what you were doing. You were simplifying the 2 tenths, but make it 1, and this is now 1/5. The answer is 1 and 1/5, not just 1/5. Converting this decimal into a percent, please do not be lazy. Do the work. 1.2, the decimal moves twice. This is 120%. Yes, you can have percents larger than 100. On the bottom one, again, don't be lazy. It doesn't take very long. You have 8%. Take the decimal, which is right there, move it twice so you actually see the work, 0.08, or really 0 and 8 hundredths. Again, 0 and, 0 and, 0 and, tenths, hundredths, 8 hundredths. Now this simplifies quite a bit because 2 goes into 8 4 times and 2 goes into 150 times. But we're not done because 2 goes into both of those. 2 goes into 4 twice. 2 goes into 50 25 times. It's 2/25. You could have just divided by 4 from the start there. At the 2014 Ashburn Giant Pizza Eating Contest, several contestants were comparing the results. No need for any of that sentence. The standings show that Brian ate 93% of his giant pizza. So Brian was 93%. Trisha was 8/9. Bridget ate 9/10. So this is Brian. Unfortunately, we'll call Bridget R. Bridget will be R for here. She was 9/10. Well, the problem is these are all written as different ways, so we should make them all the same. If we convert them into decimals, I'm not going to be lazy, 93%, take the decimal, move it twice. This is 0.93 or 93 hundredths. 9/10, I know what 9/10 is, it's 9/10. I know how to do that. You could have divided, but 9/10 is 9/10. 8/9, we divide this very quickly. Does 9 go into 8? Remember the top goes to this side. 9 does not go into 8, but 9 goes into 80. 9 times, set this up, and the top, 9 goes into 80 8 times, which is 72, with 8 left over, zeros drop from underneath. 9 goes into 80 8 times, 8 times 9 is 72, with 8 left over, zeros drop. So if you notice, it's 80 every single time, so it's 8 with a repeating bar, 0.8 with a repeating bar. So who ate the most? The answer is Ryan ate the most. If the results show that Christina, so now we have a new contestant, Christina, more than Trisha, but less than Bridget, so Christina's somewhere between those two, what is a possible percent that she could have eaten? Well, if we know it's higher than 0.88888, but lower than 0.9, which is of course 0.90, the percent is going to be somewhere between 90% and 88.8 repeating percent. So what's a number between 90 and 88.8? Well, the common answer would be 89%, or somewhere between those. Could you have done 89.9? Sure, but somewhere between those two numbers was your answer for number 6. Number 7 is asking us to sort of switch gears and start talking about squares and square roots. So let's look at the model. Which statement is represented by the model? Well, this is a square, which is 17 by 17. So how many boxes are in here for 17 by 17? Well, if you count, you could count them all, or you can just realize 17 times 17 is 289. So, is 7 times 2 34? Well, it is, but that's not what's being modeled here. Is the square root of 17 4.12? It is, but no one's taking the square root of 17. Is it 289 divided by 2? Well, there are 289 boxes, but why would you divide it by 2? What does that even mean? Are you going to split this thing in half? It's not dividing it in 2. The answer is the square root of 289 is 17. What's saying is, if this square is 289, what number times itself would give us 289? In other words, what number squared is 289? Well, the answer is 17, because the square root of 289 is 17. That's right, 17 times 17 is 289. 17 squared is 289, so that should be 289. So the answer is choice D. Continuing along with square roots, let's figure out what each of these are. The square root of 9 is 3, the square root of 49 is 7, the square root of 36 is 6. So what I need to do is put them in their proper spots. This is 1, 2, 3, also known as the square root of 9. 4, 5, 6, also known as the square root of 36. And 7, also known as the square root of 49. It's that easy. Number 9, Sarah is planning to put a square patio in her backyard. She needs an area of at least 130 square feet at least. So it could be more than 130 square feet to fit all of her patio furniture. She wants it to be a square, and she needs at least 130. Estimate the length of each side of the patio to the nearest whole number. Draw a picture. Well, if we had a square, and let's take a guess. We made it 11 by 11, 11 feet by 11 feet. It's a square. 11 times 11 is 121. She wanted at least 130. So 11 is not big enough. So what if instead we made it 12 by 12? Well, 12 times 12, since it's a square, is 144, which is bigger than 130. So round to the nearest whole number, the least that it could be would be 12 feet on each side. The length of each side is 12 feet. Number 10 says to circle the true statements. Some of them are flip-flopped backwards and forwards, so you guys need to be aware that just because the square is on the right-hand side doesn't mean the statement is not true. Let's do the first one. Is 18 the same as 324? The square root of 324. If you're not sure, we know that this is 18. What's the square root of 324? Also 18. That's the same thing. It is true. A lot of students think, oh, square root, divide by 2. Square root of 18 is 9. No, it's not. The square root of 18 is not a nice number. It's a little more than 4. This is not true. Again, same idea. Some students think, oh, I'll just divide it in half. Square root of 150. No, it's not. What's the square root of 100? 10. 10 times 10 is 100. 50 times 50 is 6,250 around there. That's wrong. Oh, sorry, 2,500. 55 times 50 is 2,500. Let's look at this one. 8 equals square root of 64. Well, what's the square root of 64? 8. That is true. 15 equals the square root of 256. Well, what's the square root of 256? You have to have them memorized. It is 16, not the same thing. Again, going back to the exact same question as these ones. A lot of students think, oh, square root of 12 divided by 2. Nope. Square root of 12 is not a nice number. This is not true. Square root of 169, is that 13? Well, yeah, 13 is the same as 13. That is true. Square root of 400, is it 40? Nope, it's 20. 20 times 20 is 400. Not the same. 6, is that the same thing as square root of 36? Yes, square root of 36 is 6. That is true. Square root of 144 is 12, and 12 is also 12. Those are the true statements. And the only true statements, so you can see it clearly, the only true statements are these 5. Number 11 asks you to find the perfect square closest to the following numbers. Just gonna have to have it memorized. 121 is the closest one. If you're not sure, you can just do and guess. Well, I know that 10 times 10 is 100. 11 times 11 is 121. That's 4 away. 65, if you're not sure, well, 7 times 7 is 49. 8 times 8 is 64. Oh. And then 9 times 9 is 81. So the closest one is 8 times 8. Looks to be 64. Square root of 171, gotta know your perfect squares. If you, again, you do 13 times 13, you get 169. But if you do 14 times 14, that's 196. So it's 169, which is 13 times 13, and 196, which is 14 times 14. This one's closer, so 169 is the closest one. 370, that's really close to 400, which I know is 20 times 20. But what's 19 times 19? That's 361. 361 is close, that's only 9 away, that's 30 away, so the answer is 361. Number 12, put the following in order from least to greatest. The radicals make it crazy, so here's what you can sort of do. You can put them in order based on what it's closest to. Square root of 14, that's a little less than the square root of 16. So it's around about approximately 3.9-ish. Square root of 45 is a little less than the square root of 49. So similar to what we just did up here. So it's a little less than 7, that's 49 is 7. So it's like 6.8-ish, let's say. We know what the square root of 25 is, it's 5. Square root of 90, well, we know that it's between, it's like close to square root of 81, close to square root of 100. So it's between 9 and 10. So we wanted to approximate it that way, we'll just call it 9.5. Even if you're not sure why it's 6.8 or 3.9, but you know it's between those two, just put 6.5 and 3.5. That'll help us for this one. So now we're looking at 2, 3.9, 6.8, 19.5, 9.5, and 100. Just to put it in order from least to greatest, well, clearly 2 is the smallest. Next is 3.9, or the square root of 14. Next is, looks like 5, or the square root of 25. Next is 6.8, or the square root of 45. Then we have 9.5 before 19, square root of 90, then 19, and of course the largest one by far is 100. Don't make that 10. It didn't ask you for the square root of 100, it just asked you for 100. Number 13, again, changes gears again. We're going to talk about exponents. 10 to the third power is 10 times 10 times 10, or really 1,000. 10 to the second power is 10 times 10, or 100. 10 to the first power is just 110. So if you're noticing what's happening, each time from here to here, when the exponent goes down by 1, the decimal is moving over and shortening things up. So you might think, well, I'm losing a 0. That's not actually what's happening. The decimal is moving over to make it 100. The decimal is moving over when I go down by an exponent to make it 10. And the decimal is going to go over to make this 1, because anything to the power of 0 is 1. 10 to the negative 1, again, the decimal is going to move over again, 0.1. And the decimal is going to move over again when I lose an exponent, 0.01. So the exponent moves the decimal down. Negative exponents do not make things negative. Negative exponents move the decimal, or really take that fraction, that base, and move it to the denominator. Continuing this concept, write each negative exponent as a fraction in a decimal. I know if I move to the denominator, it's 1 over 10 to the positive 3, which would be 1 over 10 times 10 times 10, or 1/10 times 1/10 times 1/10. Either way, it's 1 over 1,000. This and this, they're all the same thing, 1,000, because 10 to the third is 1,000. And 1,000 is, as you all know, tenths, hundredths, thousandths, 1,000. 10 to the negative 4 is the exact same idea, 10 to the positive 4, which is, again, the same thing, except another one, and another one, and 1 over 10,000, which is tenths, hundredths, thousandths, 10,000ths. These are questions you should definitely know how to do for your test. Number 15, it says the circle of numbers that are written in scientific notation. Scientific notation is always a number between 1 and 10 times 10 to some exponent. This number has to be between 1 and 10. This is not scientific notation. This is not between 1 and 10, not scientific notation. This is between 1 and 10 times 10 to some exponent, scientific notation. This is, again, not between 1 and 10 because it's less than 1. This is not scientific notation because it's bigger than 10. This one is between 1 and 10 times 10, and it has an exponent. Yes, exponents can be negative. G, again, not between 1 and 10, it's less than 1. And H, between 1 and 10 times, oh, it's times 12, not times 10. Not okay. There are only 2 that were written in scientific notation. Doing number 16, since the writing number in scientific notation, this is not the time to be lazy. So we have 7,000. Take the decimal, which is right here, 1, 2, 3 times. It's 7. You don't have to put 7.000, just 7. times 10. How many times did the exponent move? 1, 2, 3, move 3 times. Is it a positive 3 or a negative 3? Well, big numbers are positive. Big positive, small negative. Big positive, small would be a negative. Small will be a negative, big will be a positive. 7 times 10 to the positive 3. C, 0.003. Don't be lazy, write it down, actually do the work. 1, 2 has to move to here, which is the number 3. 3 times 10, it's always times 10. How many times did it move? 1, 2, 3. However, this is a small number, so it is a negative 3. Please don't put 3 to the negative 3. It's always going to be 3 times 10 to the negative 3. Always going to be times 10. B, again, don't be lazy, 0.00124. Take the decimal, no, no, yep. 1.24, do you need the 2 and the 4? Yes, you do. Times 10, how many times did it move? 1, 2, 3. And again, since this was a small number, it is a negative exponent. It's just a coincidence that it's been 3 all of these times. Let's do the last one, which is D, 24,840,000. Take the decimal, which is here. No, 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 yes. 2.484 times 10. How many times does this number move? 1, 2, 3, 4, 5, 6, 7 times. And it is a positive 7. I kind of ran out of space already again here. 2.484 times 10 to the 7, because it is a big number. Big positive, small negative. Big positive, small negative. Number 17 asks us to draw a line to connect which ones are equivalent. Well, they're all 1.3 if you notice. This is really just asking you if you know how many times it moves. 1, 2, 3, 4, 5. It moves 6 times to get there. Is it a positive 6 or a negative 6? Well, since it's big, big is positive. This one moves 1 time. If it moves 1 time, is it a positive 1 or a negative 1? Well, negative 1's our only choice, but we know negative is small. It's negative 1. This one moves 1 2 times to get to the 1.13. And since it was a big number to start, it is a positive 2. This one moves 1 2 3 times. Now the question is it positive 3 or negative 3? There's only 2 left. Well, since it was a small number, small is a negative. And that leaves 1 2 3, and big is positive, so it sort of looks something like that. Question number 4, should 4 students answer the question below? Which student did not answer the question correctly? Why or why not? We know that a negative exponent does not make things negative. So since Heather made this negative, it means she was incorrect. You might think Derek was wrong, but a 10 to the negative 3 is, as we talked about earlier up here, it's tenths, hundredths, thousands. This one is correct. Janet did the same thing. 10 to the negative 2 is tenths, hundredths. And anything to the power of 0 is 1, so Heather did not do it right. We know that negative exponents do not make things negative. Negative exponents do not make things negative. And the last 2 questions ask to list the numbers in ascending order, which is going up. This one says descending order, which is going down. Either way, we're going to make them all the same. Let's turn them all to decimals. This one becomes 0.018 when I move the decimal 1 2 times. This is 0.04 when you convert. This is 1.3 repeating. This is 0.01. This is obviously 0.02. We know that 1/10 is 1/10. So when we put them in order, we compare 0. This is 0.1, 0.4, 0.1, and 1 is 0.2. So this is 0.18, 0.1, nothing. So 1% comes first, right, the original. Then 1.8 times 10 to the negative 2. Then 0.4, 0.2, so 0.02 is next. Then 0.04, or 4%, is next. Then I have 1/10 and 1.3, so 1/10 is next. Let me write it the proper way. Excuse me, write the original 1/10. And then 4/3 would be the last thing. And the last question down here says to list the following numbers in descending order. Now I could convert them all to decimals, but here's what you need to know. If you look at the exponents, that will tell you the biggest one. 9, bigger than 0, bigger than negative 9, bigger than negative 9, so this is the biggest one, 1.1 times 10 to the 9th. Next is negative 9, negative 9, 0. 0 is the next biggest, 9.999 times 10 to the 0. Note that the numbers up front don't matter until we reach these guys. In these guys, you'll see, since they're both negative 9, now we got to go to the numbers out front. You might think 25 compared to 8. Nope. Go in order. 1 to 1, 2 to 8, 8 is bigger than 2. 1.8 times 10 to the negative 9, and followed lastly by 1.25 times 10 to the negative 9. Make sure you take your time, and I did not here. Make sure you show your work. Convert them all in decimals and show your work. So show all of your calculations, then write your answer down here using the original on both of those.